In this video, we show how to divide continuous data measured in naturalistic environments into separate daily activities. We want an average value for all available outcome variables for each daily activity, so we can compare autonomic nervous system activity and reactivity between persons across comparable activities. In the previous video on data labeling, we explained how to label data that was recorded during an experiment. There, we used a combination of the marker button and noted start and stop times to divide the continuous data into separate activities, to make sure we didn't mix up these activities. As you can imagine, it's not easy to pinpoint separate activities within measurements in naturalistic settings, where people walk around unsupervised, as you would do in a laboratory or a supervised ambulatory experiment. Unless the participant is instructed to press the marker button on the VUAMS device at the beginning or ending of a certain event. You would do this when you are, for example, only interested in certain events such as panic attacks, anger moments, euphoric moments, etc. During unsupervised ambulatory research in naturalistic settings, it is common practice for subjects to wear the device during an entire day. Subjects are instructed to write down what activities they engaged in during the past half hour, or to enter such activities in a smartphone or other handheld device, resulting in a summary of their activities each half an hour during the entire day. Sleep is usually noted by the start time upon going to bed and the stop time written down upon awakening. The activities within these half-hour self-reports need to be translated into label categories afterwards, which brings its own specific issues and solutions in contrast to experimental data. For starters, we need a different label configuration file than when working with pre-planned activities under supervision, as is common in experiments. We now need a flexible label configuration file with multiple layers per label, to be able to capture most daily activities of interest within your population, and also without creating too many or too specific categories. The act of labeling is exactly the same as with data collected during an experiment, with the exception that you now have to choose from more than one main category in the pop-up screen to create a label per unit of data. So click and drag in the Add Label bar and choose the appropriate values for the available categories. Watch the tutorial video for labeling experimental data for a more detailed explanation on labeling itself. In ambulatory research, the most challenging part of labeling is usually the interpretation of the self-report diaries. In general, various activities are reported for each half-hour diary entry, not necessarily in the order of occurrence. So the challenge lies in identifying the start and end times of the individual activities within this half an hour from the description in these self-reports. However, it is often difficult to interpret these self-report diaries. Subjects are not always capable of accurately describing what they have done in the past half an hour, or they mix up the chronological order of events. To aid the interpretation of self-reports, we can use the motility and heart rate signals. These signals help you easily detect transitions from one activity to the next, and to distinguish between physically less or more active periods. Most changes in activities, for instance, going from sitting behind one's desk to standing and talking, are accompanied by sudden changes in the motility signal. These changes can be used to determine the exact start and stop times of the various activities reported in the diary. The motility signal further has three aspects that will help you identify different types of physical activities more easily. First of all, the amplitude of the motility signal is a good indicator for intensity of the ongoing physical activity. It is usually flat when sleeping or when engaged in low-intense physical activities, and the amplitude increases during more intense physical activity. Second, the shape of the motility wave can tell you something about the type of the ongoing physical activity. It becomes more like a sawtooth when making repetitive movements such as walking and biking. During walking, regular placement of the feet creates a sawtooth-like waxing and waning signal, and the amplitude of the sawtooth peaks become larger as intensity increases, like when climbing a staircase or when running. In parallel, there will be an increase in heart rate. Cycling, however, also creates a sawtooth-like pattern with high heart rate, but the sawtooth peaks have smaller amplitudes than expected based on the heart rate, as the impact during cycling is lower than during walking. This is how the use of the motility signal in combination with the heart rate signal and self-report diaries can greatly help you detect individual activities like walking, bouts of stair climbing, or bicycle rides.